Hello, everyone, and good morning or good afternoon, depending where you're at. My name is Derrick Lavado, and I'm with the Wind River Operating Systems Business Unit. And I want to thank you very much for attending my track today to talk more about security and internet security and what we're seeing in the industry right now, and really talk about some of the foundational concepts for securing edge devices. So really briefly, I'm part of Wind River's Operating Systems Business Unit, which is responsible for our core technology products. Some of them you might already be familiar with, such as our industry-leading real-time operating system solution called VxWorks, and all the safe and secure platforms that are part of that group of solutions. Also, you might have heard of our commercial embedded Linux solution called Wind River Linux. So those are just a small fraction of all the solutions we have, but that's really what our group looks after. And I'm going to go ahead and share the slides here, so just a moment. Great. So today we're going to talk about some of the foundational concepts for securing edge devices. But before we get into that, we want to take a look at what we're seeing for some of the security risks in the software-defined world. So really, an IoT software is really defining everything on how we manage devices, how we bring them online, and all the services that surround IoT are, while they're fantastic, they're also entry points for security risks. Then we'll take a look at how we address security. What are some of the foundational concepts that we look at? And it's not just the technology side of it, but there's also the things you have to think about, like your development process for security, and some high-level concepts there as well. And then there's also when the devices are deployed, you have to think about how you're going to maintain those devices to keep them secure. Lastly, we're going to look at one of our relatively new solutions called PULSAR Linux. So a lot of the foundational security concepts we'll talk about today are already packaged in this solution. So it's an easy way if you're thinking about enabling security in some of your IoT devices. Maybe it's not your background, or really it's just something that's costly for you to do as a company, and you want to focus on your application development. We have something that's off the shelf that handles a lot of the things we'll talk about today. So I'm going to spend about 2 minutes telling you about Wind River in case you don't know who we are. But our software has been deployed in over 2 billion devices. And really, our software does extremely well in critical environments where you need high availability, real-time performance, safety, and security. We're over 30 years in the industry, founded in '81. We went public in '93 and acquired by Intel in 2009. So we are a division or subsidiary of Intel. We command market leadership for real-time operating systems for VxWorks, but also we're the commercial embedded Linux leader. But beyond operating systems, we have a very broad portfolio to address IoT from sensor to cloud. And you'll see some of those technologies in the discussion today. Just a snapshot at some of the industries that we focus on. So if you look at how our government defines critical infrastructure, there are any assets or services that are critical or vital to an economy or society in general. And these are all of them here, and really defines all the markets that we go after. So anything from the energy sector, industrial, agriculture, transportation, and aerospace and defense. So you'll see a lot of our solutions doing very well in these sectors. So let's start to talk about what we're seeing as far as cybersecurity and in a software-defined world. So to really simplify topology in IoT, we'll start with the layer at the bottom where you're looking at devices or sensors and gateways. And all of those things are on a common network and peer-to-peer. Going up from there, these devices may go into an intermediary step in a fog network. So probably heard the term fog a lot. It's become in our industry where customers want to provide telco reliability, quality of service, and just have better control over managing some of their services locally instead of relying to put everything up into the cloud. So you'll see a lot more of that, in the embedded or industrial space. And then, of course, from the fog network, you have the cloud, where all the manageability happens, the data analytics, platform as a service, all those typical use cases or applications. So the message here, though, is between all these different steps, whether it's an east-west peer-to-peer communication network or north and south in the cloud, each one of these connecting points or communication areas are threat vectors or points that an attacker can exploit. And we've seen this happening over the last several years with some examples here I'll share with you. So for one, you might have heard of the Mirai botnet malware that happened. So that one had essentially taken over thousands of IP-based cameras, DVRs, and gateways and created a massive internet outage. And it took down some DNS service providers in North America. You might have heard Target, the big box retailer. So that was an interesting example of, you hear OT and IT integration, OT being operational technologies. So it could be, factory automation devices. It could be HVAC for, energy management in the building. But when you take those devices and try to integrate them into a corporate enterprise network, that opens up new security potential security breaches and threat vectors. So in Target's case, they had HVAC equipment that was compromised by some malware that eventually found its way into the corporate network. You may have heard of the Ukrainian power plant, where about 20 to 30 substations were basically shut offline, and about 200,000 Ukrainians were without power. And lastly, now there was some professional hackers, so it was actually in a staged environment, but professional hackers that were able to hack into a Jeep vehicle. And it's quite amazing. Once they were in, there was really no boundaries to what they could exploit. They exploited anything from the entertainment system, being able to turn up the volume, turn it off and on, the air conditioning system. But the really concerning part is they were actually able to manipulate the drivetrain. So they were able to actually steer the vehicle at low speeds. They could even shut off the vehicle as well. So very concerning. So with that in mind, the next thing to consider is the complexity of software and how it's growing over time. So as the user experience becomes more and more rich and the services that are provided, obviously the code is going to continually increase over time, where you look at the Ford F-150 launched in 2016, had an amazing 150 million lines of code. And now, these are vehicles that we're not even talking about autonomous driving yet. And this is only going to be, only going to grow as far as the software complexity. So the message here is, as software becomes more complex and grows, it's additional entry points that attackers can infiltrate your system that you have to be aware of. So, what are some of the high-level things you need to be thinking about when you're designing an IoT system or an edge device? So really, it starts with the silicon. So besides the chip that you're using, also what are some of the security features, or if you're using things like a trusted platform module that you need to integrate that provide that foundational level security. On top of that, what's the software infrastructure So it's the software to enable the security that's built into the security devices or chips you have on board, but it's also your infrastructure to be able to manage and update those devices securely and authenticate them and authorize those systems and account for them. The next thing to think about are your development tools. So are you using development tools that are, provide VKMs for, creating your application in a secure method? So that's definitely something to consider. And the last thing to think about is security doesn't stand still. So let's say you have a great foundational device with a lot of the silicon and software infrastructure parts of security taken care of. Providing maintenance to an edge device is critical. So even though it's secure today, it may not be secure tomorrow. So constantly monitoring as threats come out, bugs in your code. It's critical to maintain that device over time for the life cycle of it. So to double click a little bit more on this topic, so these are the three fundamentals you should really consider when deploying an IoT device or an edge device. So, we talked about the foundational hardware or the chip side of, a platform. So having the hardware and the software providing security through common technology like a trusted platform module, providing secure communications to the device, being able to do remote attestation to make sure that the device is a secure device and it's not an attacker or a decoy device, and then the security monitoring on the device itself. Then there's the operational aspect of it. So what's your security alert and response process? So as vulnerabilities are uncovered in the market, what is your demonstrated response process to alert your customers, to update them? Beyond that, how do you develop your products in a secure fashion for best known methods in the industry? And then lastly, the manageability part of it. So how do you provide these updates to your end customers, over the air or whatever other medium that you use to provide those secure updates? Then the last part of it is the life cycle part of it. So I talked a little bit about it in the last slide, but providing the bug fixes or security patches over the life cycle of your device, and then also monitoring the common vulnerability exploitations that are put out by the MITRE Corporation, monitoring those to see which ones affect your solution. And then the challenge is, most of us probably on the call today, we're in the embedded market, so it's providing it over several years of a long-term, stable, distribution of Linux. So, embedded applications are typically 5 years, they can be 7 years, or even beyond. So how do you provide that software maintenance over that time? Especially if you're using Linux, there might be some general updates or maintenance provided by the community initially, but as time goes on, that's going to wear off and more of that becomes a burden for you. And one thing I'd like to summarize from these fundamentals that you should consider, one thing that's difficult is a lot of these things are things that are really costs of developing your solution. It's not something that you can really monetize, because customers, how they consume products today, a lot of the security backend that happens or that you built into your solution is not a line item they're going to pay for. It's an expected service that your device provides, and they're really only willing to pay for the services and applications on top of that device. So you really have to ask yourself, if this is something that I want to do internally, is it part of my value add that I can monetize, or should I look to partner with somebody to do that? So let's actually talk about some of the concepts for security and some of the actual features. And really today for edge devices, I want to focus on the first two areas. So really the hardware and then the foundational software security. And then we can talk about some of the other ways to secure a device at the more security intelligence level. But really what we're talking about today is the foundational concepts in the first two blocks that you should be considering when you're developing an IoT or an edge device. So first, we start with the hardware. I mentioned the trusted platform module a couple of times. So providing that, a TPM for identifying your system, providing root of trust, protected storage, and crypto acceleration, and trusted execution. So all those features to make sure that when you're booting a device, you're booting it from a known protected source. You're encrypting your storage so it can't be tampered with, and then making sure that you're managing the device that you expect by identity, and again, not in a decoy device. The next layer, we go into the foundational security, or the software that really unlocks all the features that you would find in a trusted platform module. So again, providing cryptography, storing your certificates for your TPM module, providing your public keys or how to manage the keys for your security, provided protected communications like TLS or SSL, protected access to the system, and providing auditing and logging. Secure boot and initialization, again, having a way to store a known secure root of trust or image. So when your device boots up, it knows that is an untampered image of the boot sector. And then providing a trusted execution environment. So things like driver signing, and again, being able to measure the boot sector of the system and make sure that it hasn't been tampered with. On top of the foundational security pieces, then we have enhanced security. Some of it is still related to some of the things in the foundational or TPM, so like having measured boot and initialization. But beyond that, it's providing secure updates to your devices, so it could be over-the-air updates. And so how do you connect and provide attestation to know you're connecting to the device that you should be, and providing a secure update, and then the device itself knows that the package it's receiving is from a known source, and it's the drivers have been signed, etc. Providing secure separation, and then having policy management or role-based access control, and then get measured boot and initialization, which we covered. Now, the last part, I'm not really going to get into this that much, but I think, when a lot of people think of security, they're thinking more of the security intelligence. So, doing the virus scanning or intrusion detection and prevention, analytics, or deception-based security, providing a decoy network or honeypot. And I think that happens a lot when you're trying to converge OT and IT. I think a lot of people's experience is more on the IT side and think of more of the security intelligence side. But it's really these foundational security concepts that are critical in designing an IoT device, especially as you look at the numbers. A lot of you probably heard, 25 billion devices by 2020, and then the numbers are growing from there for IoT devices coming online. So the foundational security on those edge devices or IoT devices that you see here become more critical. So Wind River addresses security and really in three ways. So it's looking at securing your devices and services. So whether you're implementing a single standalone device or end-to-end system, the device or service is the foundational component of cybersecurity. And so we start with securing those devices and services. So that includes things, again, we mentioned like secure boot initialization, encryption, protection act or access protection. The next part is providing secure communications. So it's the authentication and authorization for devices, integrity and authenticity, and also protecting communication interfaces against attacks. One important thing I want to mention here is when we think about protected communications, a lot of people will think about it over a typical IP or Ethernet network. But when we're talking IoT, it's more than that. There's serial networks out there in the industrial space. It could be an existing serial network that you have to interface into to unlock the data and bring it to the cloud. So that's one of the areas where Wind River is really strong. Whether your device is on a serial network or Ethernet, wireless, we have experience in all those mediums and understand how to secure devices over those platforms. And then the last part is, I mentioned that one of the key things is providing maintenance for your platform, because security doesn't stand still. So we have an active security monitoring process that we provide for all our products, including looking at what CVEs are coming out and seeing how those affect our products and providing fixes and alerts over that. And I'll talk a little bit more about that in coming slides. The other thing I want to mention is, being a subsidiary with Intel, we unlock a lot of the major security features that Intel has that are built into their platform. So again, Intel's TXT or trusted execution, hardware, software, platform identification, protected or trusted boot and storage, and then AES, encryption acceleration. Any of those Intel features we can unlock and help manage those solutions. So I mentioned earlier that beyond the technological and the operational parts of security, there's how your development process and how do you develop your products to make sure it's in a secure fashion. It could be by your development process internally. It could be by the tools that you use. But I want to share you a high-level overview of how we implement our security development process. So really all the phases here are separated and provide checklists before we go into any of the next phases to make sure that our solutions are being developed in a secure fashion. This is a process. The process you see here, although it's very overly simplified, is something that we've developed over years and years of experience in working in, either medical or government or general network security environments, and a process that our customers have audited us, have asked us to audit at times. So it's a very stable, best known practices in the industry. And below there, not only do we have our own processes and testing, processes internally, but we also work with some of the leading security service partners that you see down there to help us with things like doing static analysis on our solutions, or robustness testing, or even doing vulnerability scanning on our solutions. The next thing is really how do you, once you see that there's security alerts in the industry, what's your response process to do that? So this is how we do it, again, in a simplified manner. But we're constantly scanning the CVEs, or again the common vulnerability exploitation database that the MITRE Corporation puts out. We get feedback from our customers, and we take all this data, and our product security response team quickly analyzes, first of all, what's the critical level of the CVE. There's 4 levels, so the top 2 are really the ones that are the most critical that could affect your product. So we categorize those, and does it affect our product? If it doesn't, we have a general notification of it on our support system, or OLS, which stands for Online Support System. If it does affect our product, then there's a proactive OLS notification pushed out to our customers. A defect is filed in our system, and our engineering team provides a patch and also pushes out that notification to customers actively that you can download this patch. And this is a pretty quick process. I mean, if we're talking a level 4 or critical alert from the CVE, there's times where we had a patch within 24 hours. So another reason why I want to talk about this is something really you need to think about when you're supporting your customers and maintaining them. What's your process to address any malware releases that come out? And is that something that you want to do, or do you want to have a third party partner to help you with, like a Wind River? So this is to show you how many alerts are coming out in the industry, how Wind River addresses those alerts. And so starting with the top there, those are the raw numbers of all the CVE alerts that come out from MITRE. And you may look at year 2014 through 2016 and say, hey, wait a minute, the numbers are actually decreasing from 7,900 to 6,450 or 49. But the thing you're not seeing behind that is, I mentioned there's 4 classifications of the severity of the threats, with the number 3 and 4 level threats being the most critical. The numbers of the critical threats coming out are actually increasing. So while the overall numbers are decreasing, the numbers that you really need to address that affect your platform are increasing. And that's why you see that number in the red there actually getting closer and closer to being a one-to-one match on the fixes that we provide over the alerts. So you can see, for example, in 2016, there is 6,400 alerts, and we provided 5,100 patches, or over 5,100 patches, and that's covering 4 product releases. Just this is a brief encapsulation of our product portfolio and how we address security. So starting with devices, or edge devices or gateways in the bottom, we have device agents, specifically our Helix device cloud solution. We have device agents to put on those edge devices for manageability and secure updates. We have PULSAR, which is PULSAR is a relatively new product that's spun off from Wind River Linux that's perfect for IoT edge devices, and I'll talk more about that next. And I'm not going to go through each one here, but so to summarize, the bottom portfolio is more of the operating system or platform level. And when you get into the titanium solutions in the middle there, that's for the fog network. And then on the top there are cloud devices. So we have Helix Device Cloud I mentioned. We have our Helix Car Sync for the automotive industry for over-the-air updates, and then Titanium Cloud. Okay, so I wanted to introduce to you a product called PULSAR. And a lot of the security concepts we talked about And a lot of the operational concerns for security that I mentioned are all packaged within the solution. So, I mentioned, there, a lot of these things that you have to be concerned with are not necessarily things that you can monetize. So, maybe your product is the way you go to market. There's a way for you to monetize those security services to your customer. But more and more, we see OEMs that really want to focus on the application layer and the service models they want to provide customers, and have a partner, whether a hardware partner or software partner, take care of more of the foundational, platform solutions and the security part of it. So what is PULSAR? Well, first, let's look where it came from. Customers who bought Windows or Linux from us historically would get our open source reference BSP from us. They select a target hardware platform from an OEM, and they create their own distribution and then maintain it themselves, and then provide, put applications on top of it and customize their user space libraries. What PULSAR does is we take care of those steps 1 through 4 that customers had done before. We partner with an OEM, come up with a target platform and solution, create a certified binary that has the BSP in there. It also has all the open source compliance documentation behind it if needed. And we provide a platform that simply a customer can take and provide or put their applications on top of, or even extend the operating system by adding modules in there. And it's a commercial ready operating system. One of the key things of PULSAR is it is a container-based operating system. So if you're not familiar with containers, it's a very easy way that you can update and provide new applications, and also separate them from other applications. And also, it's a way that you can provide code reuse. So if you have applications you built on other distributions of Linux, it could be Red Hat or Ubuntu, you can easily run those on a single platform. And of course, one of the big advantages with containers is it's a much lower overhead than virtual machines, where you actually have to provide a virtual board and a virtual operating system. So it's very streamlined and efficient. For PULSAR, we have what's called the security framework that's built into it and addresses a lot of those foundational security concepts we talked about earlier. And it really unlocks all the features on Intel Trusted Platform module. So for a quick review, you can see some of the features below that we support. So Linux Secure Kernel, IMA, secure storage, root file system, storage encryption, package signing, and all the others available features there. And we have pulled some of the best-in-class parts of our other Linux solutions, either from our virtualization profile or carrier grade profile and security profiles, and built that technology into the PULSAR image. Really quickly, just for review, so these are some of the typical Intel security features you'll see in the chipsets that we support. And so, while we're talking about PULSAR and our commercial Linux solutions today, we absolutely support those features over our other products like VxWorks and then our Titanium Cloud solution. So there's some of those security solutions you can see there. So another very important feature that PULSAR provides, and is also one of those life cycle concerns that you need to think about in securing your device, is maintenance. So for PULSAR, we've created a custom software repository specifically for the PULSAR image and the ODM hardware board, where a customer can go and log in and pull any of the packages or security fixes directly to the unit and install them in the containers. And it's something that's included out of the box. So if you go to one of our hardware partners or ODMs that have a certified PULSAR solution, the maintenance is already included out of the box. There's no additional licensing you need to get from us or support contracts. It's included and it's provided over the life cycle of the PULSAR release. And in some cases, that's up to 5 years. So again, that's important in securing your device as obviously, a device that's not updated and maintained, it's not secure. So what does PULSAR look like in one of the certified binaries? So this is an example of a gateway or IoT gateway solution we had done with our ODM partner Advantech. And they actually have 2 solutions. They have the UTX 3115 and 3117 gateway. And so in working with them and defining their solution, we created a gateway container that includes a job environment, MQTT for sensor data, Modbus, and also support for our manageability solution, Helix Device Cloud. And then, of course, all the features of the Intel Trusted Platform module and foundational security concepts. So all this technology is built into the box. It provides maintenance out of the box, and it's commercial ready. If you'd like to get more information on this particular PULSAR solution or some others, you can simply go to pulsar.windriver.com. You'll see some of our other partner products down there, and even some Intel solutions that we've done. So feel free to visit there. Also, you can go to our GitHub location from this page and download PULSAR if you want to start playing around with it. Really quickly here, one of the values of PULSAR, I'm not going to spend a lot of time, but you hear this a lot in commercial Linux. It's the total cost of ownership. And the message there is, while your initial investment costs may be extremely low, it's that software maintenance or those security breaches that come out that you have to scramble to address. And so your cost over time can spike, and it's not controllable. So if you start with PULSAR Linux, that cost is minimal, and when you buy it from Advantech, it's already integrated into the system. There's not an additional line item cost for it. So your costs really, whether there's security threats that come out or maintenance provided, it's always that single cost that's manageable. This link, we have a nice link where you can actually see what your potential development costs would be, and so it's a really, really nice tool. You can say what your development team size is, what kind of device you're developing. It could be a gateway or edge server. Put all those factors in this TCO calculator, and it'll actually tell you what your costs could be over the life cycle of that project. I think you'd be quite surprised to see how costly it could be. Lastly, one of the things with PULSAR is it is open source compliant. So if when you're creating your own Linux distribution, you have to provide FOSS and then open chain compliance. That's already included with PULSAR. So if needed, we can provide things like the SPDX file, which shows all of your Linux licenses that you're using in your solution. So again, another huge cost saver that's provided to it. So that comes to the end of the presentation. I wanted to put up some links here. Again, if you want to go find out more about PULSAR, you can go to pulsar.windriver.com. There's the TCO calculator I just talked about. You want to learn more about our general Linux security, you can go to that third link there. So that link really applies to any of our Linux solutions. So whether it be our standard WindRiver Linux or our PULSAR solution, you can find out more about that there. And then lastly, the CVE database that I mentioned that we pulled from the MITRE Corporation, you can actually go there and take a look at some of the CVEs that have been reported, just to give you an idea of how it would impact some of the solutions you're doing against a Linux kernel version. A really powerful tool, and I invite you to go take a look at that. So with that comes to the end of the presentation now, and I'm going to open it up for any questions that you may have. I also have somebody from our Wind River engineering team who's an architect. So he may have already provided some answers to your questions online, but we'll just open it up now for some questions. So the question is Wind River a complete distribution for security or just a good platform to develop our solutions? So Wind River has a complete portfolio from the platform level through a complete secure solution that you can leverage. So what I've talked about today with PULSAR, it's more the platform level where you can enable those foundational concepts for protecting the boot part of your device, and leveraging all the features in Trusted Platform module. But beyond that, we have solutions for network security that are higher up the stack. And then beyond that, we even have a professional services organization. So anything from helping you to design a secure platform to looking how you can audit that platform and providing security scanning services. And really, we have a complete solution available to you beyond the Linux distribution that we talked about today. And I also have some, you probably noticed the online chat, but also our architect for PULSAR had mentioned that the Wind River Linux is a source-based solution, and it is a distribution builder. And also some additional comments in case you don't see it on the chat room from our architect, but PULSAR Linux is a binary distribution, so it can be rebuilt if you choose. But it's intended to be extended with source and containers. I see a question. It says, just to read it aloud here, I'm really new to IoT research. And so where can I start on IoT research, including system security? Well, honestly, if you go to windriver.com, there's a lot of different areas of our site, especially under our Helix device cloud site, where you can learn more about IoT and some of the applications there. You can go to the link that I have, the third bullet there, the windriver.com /product/Linux/security to learn about all of our security solutions for open source. Also, you can go to Intel's website, and I'm sorry I don't have the specific link in front of me, but you'll see a path. If you go to intel.com, you'll see a path to get to the IoT section of their site, where there's a lot of information about different platforms that are addressing IoT and for security and system architecture. I see another question here, and maybe Jason, you can add to this, but are there particular edge devices that are more vulnerable to security attacks? I would say that's a good question. I would say edge devices, a lot of them, frankly, in my opinion, and I can't say any particular one right now, but these technologies like the TPM from Intel, these technologies, they've been around for years, but there's a lot of devices that are still not leveraging them. So there's a pretty large amount of devices out there now that, and it's hard to really to focus on any particular edge device, but a lot of them don't have those basic security, parameters in there. I think it's pretty obvious that a lot of consumer devices sitting on the edge are still, the protection is not that great in there. But, the risks of an industrial device versus consumer device is quite different. So there's economical reasons why some of the consumer devices out there may not have the same level of protection. So in general, again, it's hard to say which one would be more prone to an attack over another device, but it's ones that really don't have those foundational security concepts included. And just to add some comments here from our architect, so really any edge device that is connected to the internet directly with inbound communications is going to be more vulnerable. So, an edge device or an edge gateway is usually the first point of an attack because it has a direct connection for everything behind it. It says, so how do we talk about edge networks for or to security if edge devices are not secure? So I think the question is saying, so how do we talk to an edge device? Let's say if it's maybe a fog network or the cloud and we're talking down to a gateway device or something, how do we talk to them if they're not secure? Let's see. Yeah, so I have a comment from our architect here. So in case you don't see it and you're just listening to the audio, so the solutions we typically design are solutions where the gateway is in fact secured. So that's the problem. I mean, we can talk to devices in a secure fashion, with TLS, SSH, through VPNs, of course. And that's something, we all know about, we've been doing for years. But if the device does not have its own localized or platform security, then it doesn't matter. I mean, even if we have a secure connection, we're still opening that device to infiltrate our network by not having those core security measures integrated into it. And some additional comments here. So if the gateway is not secured, then you need to pass secure communications with SSL envelopes with the edge device. So one quick thing. About the question about Windows IoT. So we don't have solutions for Windows per se. There are times when customers have multiple platforms that they need to run, and we can handle running Windows in virtualization. But we typically don't, sell anything that's directly related to Windows. One other thing, on the manageability side of our devices, and I talked about Helix Device Cloud, our solution can run on Windows, but again, it's more of, it's not that we're providing something directly to enhance security or on Windows. It's just enabling our ecosystem to have our manageability solution, have a broader reach in the market. One other interesting point from our architect here, we can also handle data center type collidation of Windows servers or other instances using our Wind River Titanium solutions. And really briefly, if you're not familiar with our Titanium solutions, that's all around software-defined networking. So for orchestration of services. And actually we're, as far as I know, we're still the only one that provides orchestration or software-defined networking in general in a carrier-grade environment. And so that's what Titanium, that's what we're referring to when we say Titanium. Our Titanium Cloud or Titanium Edge solutions. Speaking of Titanium, so we have a Titanium solution that addresses the on-premise or fog computing element. So I mentioned earlier, we're seeing customers that aren't necessarily ready to go all in and put everything up into the cloud or cloud service provider, or they have specific quality of services or manageability requirements where they want to locally manage their network. So we have Titanium solutions to address that for on-premise. Okay, I see there's one more question. Are there solutions, either current or in development, to combat any vulnerabilities at the hardware level? Yeah, you probably see the response there. So there's numerous types of, development work that we're focused on that are aimed primarily at hardware separation as well as software isolation. Some additional comments here from our PULSAR architects. So for hardware security, you also want to look at secure enclaves. Excuse me, can't talk today. Secure enclaves and the new work around VT instructions, clear containers, and also secure memory isolation. I'm getting some additional information here. I'll share on the audio here. So, in the solutions that we have in the market today, we make use of secure boot and a 3-stage load process to protect all the text configuration files. Also, some competitive information. So this is not a solution which you can find from other OS vendors currently. So unless they're using an EFI stub loader directly, but yeah, that's something that we currently offer that our competitors don't. We do have, however, publish the sources on GitHub. That is the end of the presentation. Again, thank you very much for joining today. I hope you learned some very good concepts on security, but beyond the actual technological piece is also, the things you have to consider as far as maintenance, software maintenance, how you develop a product securely. And so a lot of those, those things you have to take into account for when you're designing an IoT or edge device. Please feel free to go again and check out our PULSAR solution and look at some of our partner solutions we have there, which again addresses all those foundational security concepts off the shelf in the hardware device. So thank you very much.